Our universe is insanely large, unimaginable, and beautifully strange. What holds it is always a new surprise for mankind. As to whatever we know yet, 8 planets are revolving around the Sun, there are asteroids, meteors, stars, and many other celestial bodies that completely form our solar system. From sending spaceships and satellites to naming comets and even researching the soil from one of them, it has all been an ongoing process. But one of the findings did starstruck the scientists. It was found that our solar system, with the farther located Oort Cloud, which is said to be located at a distance of a light year from our Sun, was in fact completely engulfed by a giant bubble. This bubble had a diameter of 1,000 light years, and something worth being considered is that the Sun is the center of this bubble. Isn't it astonishing? So this discovery shook our way of thinking as to how our solar system works. The huge question here is, are we really living inside a large bubble? To get to the answer, we first need to go back in time a little. In the year 1977, 2 spaceships, namely Voyager 1 and Voyager 2, were launched almost months apart from each other from Cape Canaveral. Voyager 2 was launched earlier among the two, and they both were projected to separate pathways. Almost 6 years after Voyager 1, it made its way to the edge of the solar system. What was strange was the findings of both devices. It was found that the farther we moved away from the Sun, the more the space density increases. We used to consider that interstellar space is a complete vacuum, but that's just not entirely true. There exists matter, extremely low in density, but it is present there. In the solar system, the flow of charged particles which are emitted by the Sun, called the solar wind, has an average density of electrons and protons is 3 to 10 particles per cubic centimeter, and it gets lower and lower the farther we move away from the Sun. The lowest density of whole space is at the edge of the solar system. The heliopause is the name of this boundary. On this boundary, the speed of solar wind or solar plasma falls to 0. The heliosphere is the space between the heliopause and the Sun. All the planets of the solar system are actually immersed in this huge bubble. This boundary has a density of protons and electrons equal to 0.002 particles per cubic centimeter. The density of particles of interstellar space that is behind the heliopause is calculated to be 0.037. Instruments of Voyager 2 depicted the density outside the solar system to be 0.039 particles per cubic centimeter at a distance of 17.9 billion kilometers or 119.7 astronomical units from the Sun. Well, this was as estimated, coinciding with the calculated. But then something strange began, leaving all the scientists dumbfounded. At a distance of 18.5 billion kilometers or 124.2 astronomical units, the density was found to be 0.12 particles per cubic centimeter. Why do we see an increase in density? To get into it, let's first know about another bubble, which is in fact much larger than the heliosphere and is definitely considered a bliss straight from the cosmos. Let's understand why we are lucky to be sealed inside 2 bubbles at once and what exactly is the relationship between them. When we look at old deep space pictures, we know we're looking at masses of luminous gases and huge clouds of interstellar dust. But talking of the last century's 70s and 80s era astronomers began their study on the fact that the galactic space surrounding the Sun was different from this picture. They thought that our solar system was hanging in a void. Coming this year, scientists at the Harvard-Smithsonian Center for Astrophysics (CFA) conducted many profoundly complex computer simulations and created a 3D reconstruction of space and time to prove that yes, we're really in a void. Their study depicted that the Sun and Earth hold the most center position of a giant bubble having a diameter of 1,000 light years, which was later named as the local bubble. Let's know a little more about it. According to some calculations, this local bubble began its formation about 14 million years ago. And for the formation, it is vital that about 15 supernovae exploded for several million years. It's believed that a series of these explosions forced the interstellar gas outwardly with the pressure of light, eventually creating a huge structure like a bubble with a dense boundary surface. Even to this day, this bubble grows in size continuously. In the early times when this bubble was newly formed, it had an expanding speed of about 60 miles per second, according to the European Space Agency's Gaia Space Observatory's collected data. And at present, its expanding speed is 4 miles per second. On its surface, 7 dense molecular clouds are present where stars are formed, these basic star formation regions on the bubble. Much to our surprise, there are several such bubbles present in the galaxy. Therefore, it's very much possible that there are other celestial bodies that, like us, are in their local bubbles. to our surprise, the Sun was not always the center of the universe. It is believed that when these explosive events were taking place, the Sun was quite far away from this area, almost 1,000 light-years away. But the astrophysicist of the University of Vienna, João Alves, explained that as the Sun was orbiting the center of the galaxy, it almost got right at the center. This was about 5 million years ago. This is established from the iron deposits from a supernova in the Earth's crust. The researchers also advised that there may be many other star formation bubbles in the Milky Way. Another astronomer, author and researcher of CFA, Alyssa Goodman, who founded GLUE, explains that if weren't spread all over space, the Sun would not have been near the middle of a huge bubble. There are plans by the research teams to map more cosmic bubbles to get a complete 3D representation of their whereabouts. By this, we can chart out the vast expanse of space and understand how these bubbles interact with others. With the opening of the local bubble, we can see the center is the Sun surrounded by 8 planets. The last planet, Neptune, is about 30 astronomical units or 4.45 billion kilometers away from the Sun than the Earth. Kuiper Belt, a collection of tiny celestial bodies, among which one is Pluto, lies right behind Neptune. It stretches almost 55 astronomical units. Further away, about 125 to 135 astronomical units, is the heliopause. So why is there an increase in density at its boundary? It's because of the solar plasma's collision with the interstellar plasma. Two streams at cosmic speeds collide at a point, of course, the density will increase. And behind this chaos, at a distance of 0.75 to 1.5 light-years, a spherical cloud of ice objects spreads. And Oort Cloud, serving the source of comets for a long time. The interstellar wind is dominant here, but still, somehow, the Sun's gravitational pull is holding the bodies. Well, how does it affect our lives? It does. About the heliosphere, we can suggest that our Earth is highly protected from high-energy cosmic particles from the center of the galaxy by its high-density boundary. And for the local bubble, we've long been found that our galaxy is in the shape of a spiral disk, with several spiral arms diverging from its center. At present, our Sun is almost at halfway in between the Perseus arm and the Sagittarius arm, and having our Sun revolve around the galaxy center makes one revolution in 200 million years, known as the galactic year. From the time man appeared on Earth, only 0.0008 of this year has passed. Along with the other planets, the Sun has crossed several interstellar gases and bubbles even when the density of matter changed drastically. So it's safe to say that the Sun is at its favorable state of existence for mankind, and that we humans are very lucky it all took place when the Sun got into the local bubble. From the basic need for plants to perform photosynthesis to act as a source of energy to mankind, we're in fact profoundly lucky. We could also say that maybe all of these events are somehow interconnected, the Sun turning into its safe state, in the local bubble, and appearance of man. Science has no answer to it, at least not yet, but we cannot neglect the fact that beautiful shades of the sky we enjoy are only possible due to the fact that we're actually in a void, the local bubble, which is practically a gift to humanity. There's also a new discovery found at the edge of the galaxy by the James Webb Telescope. It's terrifying. Click on the video on the screen.